Next, randomized block design, RBD, two-way classification. So the two-way ANOVA is an extension of one-way ANOVA. The two-way comes because each item is classified in two ways. For example, one-way classification might be soil, fertilizer, gender, political party, religion, race, etc. etc. It is based on only one classification. So either you have to classify soil in one problem, fertilizer in another problem, gender in another problem, like that. Single classification, right? But in two-way classification, we compare both soil and fertilizer, gender and political party, gender and race, religion and race, like that. So two classifications available. A two-way ANOVA tests the effect of two independent variables on a dependent variable. The experimental unit are divided into homogeneous groups which are called blocks. Within each blocks, the experimental units are randomly assigned treatments. For example, in the design, we would randomly select 60 students and split them by academic year, first year and second year. So split the students, 60 students based on the academic year, first year and second year, right? Then randomly assign students to treatment, first 30 students, and randomly assign students to treatment, 30 students. Then split them, group 1 15 student, group 2 15 students. So all the selection should be random, right? Similarly for the second group, so group 1, group 2. Then first apply the treatment A for the group 1, 15 students, no practical exam. For the group 2, so they are doing their practical exam. Similarly for the second case, that is also no practical exam, then practical exam. So then you will compare the result, right? So treatment A, treatment B, so you have to compare the results. This design may be defined as one in which external unit divided into blocks or groups in such a way that the units in each blocks are homogeneous. The treatments are assigned at random to the units in each block. The layout of RBD, right, randomized block design, using three varieties of wheat, W1, W2 and W3 in 4 blocks, 1, 2, 3, 4 is given below, right, like this blocks and varieties, right? So W2, W1, W3, W2, like that. So these are all the varieties. W's represent the random assignment of these varieties in each blocks, right? The data from various blocks using different varieties of wheat recorded in a table as per below. So blocks, varieties. So W1, W2, W3, three varieties. So we are taking the output, right? So keeping that x11, x12, x13, like that. So you are arranging that data. So x denotes the observed data obtained from the various block using the different varieties of it. Suppose these are all the yields, outputs maybe, right? So analysis of variance for two-way classification procedure. First, n is the total number of items in the given data, r is the number of treatments or rows, c is the number of blocks or columns. Then step 1, defining hypothesis. Null hypothesis, there is no significant difference between column. Maybe yields, there is no significant difference between rows, that is varieties, because here there are two classifications, that is why we are defining two null hypothesis. So alternate hypothesis, there is no significant difference between column and there is no significant difference between the rows. Step 2, preparing an calculation of ANOVA table. So classes 1, 2, 3 and values, number of blocks 1, 2, 3, and you have to write the data, given data x11, x12, etc. etc. Then first to find the row total R1, R2, R3 as usual. Then grand total G. Similarly, here you have to find the column total also. First column total, that is Ci. Second column total. That grand total will be sigma Ri, which is equal to sigma Ci. Both are equal, right? Next, then summation of Ri square by Ci. So R1 square by C1, etc., etc. You have to find each row wise. Then adding all of, you will get summation of Ri square by Ci. Similarly, you have to find the Ci square, Cj square by Rj square. For each column, you have to find C1 square by R1, C2 square by R2, etc., etc. Add up all those things, you will get summation Cj square by Rj, right? Next, as usual, sum of square. So each number, each element or each data, right, you have to square and add up for each and every row. So you will get x1 1 square plus x2 x1 2 square plus etc., etc., x1 c square, that is summation sigma xij square. Similarly, for all the rows, you have to find the sum of squares, right? Then adding all those things, you will get summation xij square, right? Next, you have to find the correction factor CF. Formula is g square by n. Then step 3, find the total sum of square, right? SS minus g square by n. Next, you find the row sum of square between varieties. So formula is sigma Ri square by Ci minus Cf. Then you have to find the column sum of square between blocks CSS, that is equal to summation Cj square by Rj minus Cf. Next, you have to find the error sum of square or residual sum of square, right? So that is equal to total sum of square minus column sum of square plus row sum of square, right? You have to add column sum of square and row sum of square. Then you have to subtract both from total sum of square. Then find the degrees of freedom. So V1 C minus 1, V2 R minus 1, V3 R minus 1 into C minus 1. Then find the mean sum of square between columns. So column sum of square by corresponding degrees of freedom, that is C minus 1. Similarly, you have to find the row sum of square, mean sum of square for rows. So MSS, so MRSS, that is equal to row sum of square by corresponding degrees of freedom, that is R V2 R minus 1. Then you have to find the mean sum of square, MESS, error sum of square, mean sum of error, right? Mean sum of square for error, that is MESS. So error sum of square ESS by corresponding degrees of freedom, V3 C minus 1 into R minus 1. Next, prepare the ANOVA table, right? So source between variation, so RSS between rows CSS, then error or residue ESS, right? Then degrees of freedom C minus 1 R minus 1 C minus 1 into R minus 1. Then mean sum of square MRSS MCSS MESS. Then next you have to find the ratio. First row, in between row FR, between column FC. So MRSS by MESS or MESS by MRSS, according to which one is greater, right? Similarly for column FC, MCSS by MESS or MESS by MCSS, according to which one is greater. Greater should be in the numerator and lower should be in the denominator. Then you have to calculate the tabulated value, right? So tabulated value, so based on the table, F table, statistical data, right? Statistical table. So you have to find the value from the data, that is FT. So if calculated value of this one FC, that is for column, is greater than the tabulated value, then hypothesis H not rejected. Similarly, row, FR is greater than FT, then H naught is rejected. That is second one, row, right? First one, column. So H naught 1 is rejected, H naught 2 is rejected. Next, if it is less than calculated value is less than tabulated value, H01 is accepted. Similarly, if R is less than Ft, then H02 is accepted. So advantage and disadvantage of RBD, randomized block design. So it has a simple layout, but it is more efficient than CRT, right? So for two-way classification is more efficient than one-way classification because of reduction of experimental error, right? So it is flexible, and so any number of treatment blocks and any number of replication may be used. So you can repeat any number of time. Disadvantages: if the number of treatment is larger than the size of the block will increase. This may cause the heterogeneity within blocks. The number of treatments is larger, treatment is more, then the number of blocks, the size of the blocks will increase. So this may cause heterogeneity within the blocks. Heterogeneity means in the blocks it will not be same in one block. Suppose if you are taking a soil, right, if in one block all the soil quality will be same, but in this case what will happen, in one block there will be different type of soils mixed up. That is what. So heterogeneity means that is the one. It is not suitable for complete block contains considerably variability, right? Variability means that is what I told you previously, that variability. If there is so many variability, so in one block, right, in a block, complete block contains so many variability, then you cannot use this one. This is not suitable. You cannot calculate accurately using two-way classification. Comparison of one-way classification and two-way classification. CRD is, that is one-way classification, results one-way, right? And whereas RBD is two-way, right? Experimental errors are large in CRD. So in one-way classification compared to two-way classification, experimental error is more in one-way classification, that is CRD. Two-way classification is RBD. Thanks.